All right, here we are, ladies and gentlemen. Today is Tuesday, and a week from right now, we're going to say, whoa, we only have a couple more days until Christmas break. We are going to continue to rock improper fractions, multiply fractions, and divide fractions, and divide whole numbers. But today, you are going to learn a new super magical math power that you can throw in the old math belt. Math man. You excited? I'm excited. Here we go. Your challenge questions, which I know you already completed, right? You're not watching the video first and then answering the challenge questions. That would be bad. You already completed it and you tried, which is the most important part. So thank you for that. Thanks for being awesome. Let's see here. We have the first thing. Well, let's just kind of pretend that this is the problem we're doing. If this was the problem we're doing, what's the very first step that I have to make? Well, remember, when you're multiplying anything that has any kind of fraction in it, you absolutely have to make it look like Mr. Krabs' eyes first. You got to have only a numerator and a denominator. And if you do not, you can't figure out the answer. Now, this is not a numerator and denominator, and this is not a numerator and a denominator, because this is what we call a mixed number right here, because it has a whole number and a fraction. It's kind of like 2.5. It's more than 2 and less than 3. And then this over here is just a whole number. So we have to kind of figure out what both of them look like as a fraction. Well, 5 is way easier. It's 5 over 1. 5 over 1, right? That is 5 wholes. It looks like 5. It's equal to 5. It just has a denominator and a numerator. This one's a little more tricky. This one, we have to actually turn into what we call an improper fraction. So we know that looks like a t. We know, I guess it's just going to look like a t. Here, I'll change the color. There, that's better. Now we know it's going to be sevenths because it already is in sevenths. We just need to take the 2 wholes and turn them into sevenths as well. Now, if you look over here, I literally have that for the first question. Hey guys, can you figure out what 2 and 4 sevenths is as an improper fraction? So what we're doing here is we are saying, okay, we have 2 wholes. Remember, each whole is 7 sevenths. So basically what you're doing is you're multiplying 7 times 2 to get 14, and then you're adding the other 4. So it's not 14, it's 18. So that's why on the first step, we figure out what 2 and 4 sevenths is, as if the entire thing was sevenths instead of having 2 wholes. So 18 sevenths is the same value, equal to 2 and 4 sevenths. Now we could simplify and then multiply. Ooh, that's a lot of plies, right? But actually we can't, because you need to be able to reduce a top and a bottom number, and you can't do that here. So even if you knew about that shortcut, even if you had that in your math belt, you can't apply it here. So we just have to multiply across. 18 times 5 is 90, and 7 times 1 is 7. So now you have 90 sevenths, but we have a whole bunch of holes we can pull out there, right? In fact, this number over here is a little bit bigger than 2. So 5 times 2 is 10. And it's smaller than 3. So 5 times 3 is 15. So if you're picking up what I'm laying down from that estimation, we know our answer is between 10 and 15. Let's pull out as many 7s as we can from 90, which sounds like division, which we're going to learn it is division, because every fraction is a division problem, and every division problem literally is a fraction. Whoa, Mr. Stahl. How many 7s are in 9? 1. Is there anything left over? Yeah, there's 2 left over. Now bring down the next digit. How many 7s are in 20? 2. How many are left over? Well, 2 times 7 is 14. So 15, 16, 17, 18, 19, and 20 are all left over. So there's 6 left over. So 6 7. So this equals 12 and 6 sevenths. Ooh, Mr. Stahl, that's gross. Yeah, a little bit. Okay, so Remember yesterday we listened to that really catchy, wonderful tune, Keep, Change, Flip. So, oh my gosh, Mr. Stahl, we're supposed to divide fractions. I can't do that. I don't like doing it. Then don't. How do you divide fractions? You don't. You multiply. But in order to change that, they need something from us. We can't change that unless we flip the last one, right? Because K, C, F. Keep, change, flip. If it is division, we can get rid of it. But in order to do that, we got to throw a keep, change, flip boomerang up at that thing. So keep 1/3 the same. Change the sign from division to multiplication, and then flip the 2 and the 3. The 2 and the 3 we're going to flip, so instead of it being 2/3, it's 3/2. Now, we can multiply across and get 3/6, or we could reduce first. See how they're both 3s? If you count by 3s for both of them, that turns this into a 1, that turns this into a 1. 1 times 1 is 1, and 1 times 2 is 2. That answer is 1/2. Okay, so 1/3 divided into 2/3 is going to be 1/2. I hope you guys understand. Now, I hope you got them right already. That tells me you already understood them. But most importantly, I hope you understood it after I explained those questions. That's the most important thing. Now, if 1/8 pounds of uncooked rice makes one serving, how many servings are in a 15-pound bag? Oh my gosh, that's a lot. That's a lot of servings, right? So the first thing you have to ask yourself in division, because order matters, are we starting with 15 pounds and making a bunch of 8s? Or are we starting with 8s and making a bunch of 15s? We're starting with 15. So that's the first number you put in the division problem. And we're dividing that into as many 8s as possible. Oh my gosh, we're going to divide with a fraction? No, we're not. We're going to keep, change, flip that thing. So 15 is the keep, and 15 is 15 over 1. We're going to change to multiplication, and we're going to flip 1/8 into 8 over 1. Oh my gosh, now we just have whole number times a whole number. So 15 times 8, 5 times 8 is 40. And then 8, 9, 10, 11, 12. So that answer is 120. That makes sense that the answer is huge. There's going to be 120 servings. That's the challenge question, but it's actually a future question. All right, what's going on here? What's going on with this? Let's see. Oh, Math Man is back in action. What's Math Man doing here? Oh, man, he's got a sweet belt. Check that one out. Oh, yeah. Oh, we're going to see what's in those compartments. Oh, I see what we're doing here. Okay, ladies and gents, we are looking at different ways to divide. Now, that's the first way to divide right there. And it's like, you just put it in a house. So if it's 50 divided by 5, you can throw it in a house. Now, you cannot see the house that wonderfully, but this is the house. The 50 is in the house. You say, okay, how many 5s go into 5? 1. What's left over? Nothing. Nothing. Everything came out perfect. And then you bring down the next number. Oh, it can't go into that at all. So therefore, that's your only answer is 110. The answer is 10. So when Math Man, which has some cool looking eyes there, when Math Man is about to encounter a little division problem, he's like, boom, I can use the house method. That's a good idea. But it looks like he's got 2 other methods here. Let's check them out. Oh, yeah. Well, that method we learned yesterday. We love that method, man. We got KCF, keep, change, flip, and the kernel agrees. It's a great method. So the example they're giving us for keep, change, flip is if I have a third and I'm dividing it by 5, and we're like, oh, no, you didn't. We're not dividing by 5. We're going to keep, change, flip. And we're going to keep a third. We're going to change the sign from division to multiplication, and then we're going to flip the 5. Now, if it is 5, that's 5 over 1, and we're going to flip it to 1/5. Now we multiply across, and our answer is 1/15. Now, last but not least, we are going to go to one last method. One last method here. Oh, you guys are going to get introduced to the slice. I love it. So, what is the slice, you might ask? or you might not be asking, so I'm going to answer you anyways. The slice is 5/7 is 5 divided by 7. 5 divided by 7 turns into 5/7 because, guys, all you have to do whenever you see a division sign, the answer's staring at you. You slice it, circle it, and there's your answer, 5/7. Whoa. Yes, that is an option. And it's actually an option for all of them. Now, you could say, Mr. Stahl, it's not an option here. No. This is not 5 divided by 50. Remember, when you see it in the house, and this tricks people always, the way that you always say in the house is what you say first, divided by 5, and it does work there. It does. 50 divided by 5, you'd split and you get 50/5. And remember, in 50/5, there's a lot of 5s hidden in there. How many are hidden in there? 10. Now, there's a reason why there's still 3 different methods for dividing, and I'll explain that here in a second. They all have different purposes, or there's different times that you'd want to use them, right? I never played that Pokemon game, but it's very similar, right? In Pokemon, you have all these cards, I think. I don't know. And then it's like, they're important for different reasons, right? You'd use one for a different reason than the other. All right, I got to get out of this analogy because I don't know much about it. But that's what's going on here with division. You use these 3 different methods for different reasons. So 3 ways to divide. You got keep, change, flip. You got the house method. And you have slice. Okay. Now, why would you use these? Well, the KCF, the keep, change, flip, whenever you're dividing by any kind of fraction, you want to keep, change, flip. So any fraction at all, or mixed number for that matter, any fraction or mixed number, you want to use keep, change, flip because you cannot divide by fractions. Whenever you have a normal division problem, so when you're dividing, 5,325 divided by 5, you'd always want to use the house method. It really helps with your normal division problems. Keep, change, flip. It's not that you'd get the wrong answer. You just look at it like, ooh, I can't do that in my head. So you don't like to use this one for the normal traditional division. And then what about the slice? Well, the slice you wouldn't want to use on these either because you could slice it, but then you're still going to have this huge improper fraction. So you're still going to need another method to divide. And then the slice method, you always want to use this when you're just dealing with small numbers, especially the numbers that have an answer of smaller than 1. So let me kind of give you some examples real quick to show you. So for example, 8 divided by 2, you could use 2 different methods here. You could use 8 divided by 2. You could use the house method and get 4, or you could just use the slice method. And you see that 8/2 is your answer. And then you see, well, how many 2s are in 8? Oh, there's 4 2s in 8. So therefore, 4 is my answer. And then you're like, oh, Mr. Shaw, what if I messed up and used keep, change, flip? Well, the answer is not going to be wrong. Keep would be 8. Change the sign to be multiplication. And then 2 is 2 over 1. So flipped would be 1/2. And then you have 8 over 1. And you multiply across. And you get 8/2, which is what we had here. And then you pull out as many 2s as possible. Right? And then you get 4. So no matter which method you use, you're not going to get the wrong answer. You're just going to see that there's different reasons to use the different methods at different times. So what about this one? Which method would you use? Oh, we would for sure use the house method on this one because it's a huge number and we have 8,002 divided by 2. And I understand that a lot of you guys don't really know the house method yet because that's something that you learn in 4th grade. And you just didn't have a full 4th grade experience. So I'm going to spend a lot of time working on these just next unit. Okay, so 2 goes into 8 4 times. There's nothing left over because it went into 8 perfectly. So I could subtract 8 and then I could pull down the next number and 2 cannot go into that. So you put a 0 And then you bring down the next number. There's nothing left over. 2 cannot go into that. So you bring a 0. And then you bring down the next number. And then 2 can go into that one time. There's nothing left over. So that's 4001. So once again, it looks like a normal division problem. You throw it in the house, and then you put the second number on the outside. So that's the house method. So what's the next method? Oh, check it out. The newest method that joined our belt family, slice. So 4 divided by 5, slice it, answers 4/5. The dividend, or the first number, is smaller than the divisor, so it's a perfect opportunity to use the slice method. So that's 4/5. 4 divided by 15 people, each person will get 4/15. 4 divided by 25, answers 4/25. And 8 divided by 9, answer is 8/9. But Mr. Stahl, what if I mess up? What if it's like 10 divided by 5 and I use the slice method on accident? No, once again, you don't mess up when you accidentally use the slice method. You'll just realize, oh, that didn't give me my final answer yet because I still have an improper fraction. I got to figure out how many 5s are stuck in 10, and that answers 2. Okay? All right. So let's go into your first problem on page I don't know. I wish I did, but you guys should be there after yesterday. It's Unit 3, Lesson 11. We're going to rock the odds together right now, and then we'll work on the evens later in our Zoom. So it says, consider the division problem. 2 divided by 5. Describe a situation that this could represent. So what the author and I would like for you to do, let's see if I can add a text, is I want you to come up with some sort of a word problem. No, of course I cannot put a text. I should be able to put a text. I'm sure there's a way. What's this one? That's not right. I might be in trouble now. Eliminate background. Oh, they can hear me talk? This is crazy. What's going on with technology? Hello, computer, how are you? Okay, I'm done. I'm sorry. That's crazy. That is, all right, I gotta stop. Is it still doing it? Oh my gosh, what's going on? All right, I guess you guys can read the captions. You know, if you're having a hard time understanding what I'm saying, that's got to be so confusing. All right, so consider the division problem. 2 divided by 5. I can't do this. If I have 2 pounds of chicken and 5 people are splitting it, that's a perfect one. Now you have to understand that the first number that you say is what you are going to literally have. And the second number is how many people are splitting it. So that's what I'm going to say. I'm going to say I got 2. You know what? I'm just going to let this do the, I'm going to let this do the writing for me because this mouse is really hard to write. I have 2 pounds. Oh, that's even worse, Mr. Stahl, of chicken wings. It's the chicken wings. And 5 people are splitting it. Sorry about the writing. 2 pounds, it looks like I have chicken wing fingers when I'm writing it. 2 pounds of chicken wings, 5 people are splitting them. How much chicken will each person get? I promise you, if I wrote with my mouse, it'd be worse. Ooh. All right. So it says, draw a diagram to represent the division. Okay. So let me make a big old bucket of chicken wings. I almost put KCF. But I mean, let's be honest. Does Kentucky Fried Chicken have the best chicken wings? No, but I'm not good at drawing a Buffalo Wild Wing. Yeah. So let's say just have a piece of chicken sticking out there. Piece of chicken. Is that a drummy? I don't know. It looks like I ordered a bunch of bread. Those are chicken wings, man. Look at that Parmesan garlic sticking out there. All right, so we're going to divide that by 5 people. So I'm going to put 5 faces. Yay. I get to eat. I get to eat. I get to eat. Now, you guys, I want you to know that you guys can totally come up with your own way. So this is 2 pounds. And then I'm going to draw arrows to each of them to show it's splitting. So is that the diagram they're looking for? Probably not, but that's okay. You guys understand there's 2 pounds split between 5. So 2 divided by 5, just like this. And my answer, I'm going to use the Sliz Ice method. Answer's 2/5. So the answer equals 2/5 pounds. Some higher level stuff right there. That's some higher level chicken wing math. Forgot this thing's chicken wing. 1 word. Interesting. Okay. Well, now it's not 1 word. This thing. Let's move on. Looks like I'm running out of time with all this nonsense. Consider the division problem. 1/4 divided by 2. Remember, division, the order matters. So the first thing that you say is what you're starting with. And the second thing that you say is how many people are going to split it. Or if it's smaller than 1, I don't look at it as how many people are going to split it, because if it's, let's say it was 2 divided by 1/4, you would not say 2 chicken wings are getting divided by 1/4 of a person. That don't make no sense. Instead, then you'd say the divisor is what you need for a group. So you have 2 and you only need 1/4 for a group. How many groups could you make? Your answer is going to get bigger that way. So right now, the divisor, the second number, is a whole number. So therefore, we're just going to look at it like how many people are splitting it. So let's go to gaming, right? I have 1/4 hour for me and my brother to play Madden, which is a video game. How much time do we each get? All right, so let's draw a diagram. This isn't the easiest to draw a diagram. Let's make it look more like, I don't know, a box that represents 1/4 of an hour. So we can even go like this. This represents an entire hour. And this is all we get right here. Here, let's change the color so it looks like, oh my gosh, that's what we get. This is what we get, and our time's running out. Let me see here. So now we want to split it into 2. So my brother and I are gonna be like, okay, that's fine. How about you get the top part, I'll get the bottom part. So now it's easy to see that if this is me, I get 1/2 of 1/4. So I get 1/8 of an hour. Once again, probably not what the author's looking for, but that's okay, as long as it's making sense and you guys get it. So let's do the problem. Now, this is a good example too of using a different method. Which method should I use here? Should I use slice or keep, change, flip? Well, let's just say I thought it was slice. If I slice it, my answer is 1/4 over 2. That doesn't make any sense at all. So slicing is the wrong method there. So it's got to be keep, change, flip. And remember, whenever you have a fraction, you want to use keep, change, flip. So let's keep. Let me change the color so it's easy to follow, or easier to follow. I'm sure this is not easy to follow. 1/4 is your keep. Change, you change from division to multiplication. And then 2, it is 2 over 1. We're going to switch it to 1 over 2. And then you multiply across and you get 1/8. So we'll get 1/8 of an hour. All right. Now we just have 3 more problems that I'm going to kind of go by quick because I only have about 5 minutes left before my half an hour is up. There's 1/6 of an extra large pizza left over in the refrigerator. If 3 friends share it equally, what fraction will each person get? So are we starting with 1/6 and splitting it between 3, or are we starting with 3 and splitting it with 1/6? Well, what do we have that we're going to break up? The pizza. And remember, order so totally matters and is very important. So we have 1/6. Wow, that was the best I've ever used my mouse to write. That was impressive, Mr. Stahl. And we're dividing that. Oh my gosh, you are on a roll. Look at the division sign. Between 3 people. You blew it. So 1/6 divided by 3. What method am I going to use for this? You figure it out. You come up with that answer. Let's go to 7. Brady has 3 goldfish. This is 1/5 times as many as Sam has. How many goldfish does Sam have? So the first thing that I like to do in problems like this is I really like to see who should have the bigger number, because it's easy to make a mistake and line this up wrong. But if you do line it up wrong and you know who is supposed to have the bigger number, you'll know your answer's wrong. Okay. So if Brady has 3 and Brady has 1/5 as much as Sam, who has more goldfish? Sam, right? Sam has more goldfish. So basically, what we're seeing is 3 equals 1/5. What in the world happened, man? You guys noticed I didn't have anything over there. I'm frustrated because I'm on a roll. This is some good math for me, or some good writing, I should say. And there's no back button. I could cry right now. That was so beautiful. Oh, wow. I guess there is a back button. All right, I don't even know why am I, okay. I hope this is as amusing to you as it is not to me. All right, so 3 equals 1/5 of something. 1/5 of means multiply, and something. I'm just going to put a box to represent something. I can put an X. What happened? Why did that happen? Okay, so let's pretend this is an easy number. 5 equals, no, 15 equals 3 times something. We know that that something is a 5. Why does that keep happening? So if that something is a 5, how do you go from 15 to 3 to 5? Oh, I know, you divide. So to find this answer, you're going to do the same thing. You are going to divide 3 divided by 5, and that will get your answer. Well, stop with that weird squiggly. All right. Once again, I'll check that in your Zoom. On Wednesday, 72 people watched the softball game. It rained on Friday, so only 18 people watched the game. The number of people who watched on Friday is how many times the number of people who watched on Wednesday. A lot going on here. These questions are difficult. So on Wednesday, 72 people watched the game. So 72 equals blank times 18. Let's see if that makes sense. On Wednesday, 72 people watched the softball game. It rained on Friday, so only 18 people watched the game. The number of people who watched Friday is how many times who watched Wednesday. So Friday equals, that's what, so scrap this. Friday equals 72 times something, and we have to figure out what something is. Okay, so let's once again come up with an easy. So, and we also know that 18 is Friday. Okay, so 72 times what is 18? And let's say 10 times what equals 5. Well, remember, half of 10. Why does that squiggly happen? So if that's half there, you go to figure out what it is here, we are going to divide, right? And you're going to take this and divide it by that, because 5 divided by 10 is 5/10, which is half. So let me just try to not confuse you. To figure this out, take 18 and divide it by 72. 18, don't do the weird thing, divided by 72 equals. You know, the weird thing happened after that those words start coming up. So I'm blaming that. Okay, so we're going to zoom, try to come up with the answers for 5, 7, and 9, and then together we'll come up with all of the even answers. And I know this is difficult. Okay, I know this is difficult. We'll work together to make sense of it. But most importantly, like this, coming up with what to do is hard. Okay, but most importantly, just when you see the numbers, you should be able to come up with the answers. Like if I say what's 4 divided by 5, you could tell me 4/5. That's the most important part. So yes, this is confusing and difficult, but Mr. Tall, what should I know? Today, if you could understand how to divide these fractions, that is the victory we are looking for. All right, I'll see you guys in our Zoom.